Sure. So yeah, thanks for recalling me every day. So like in RC, as I told you yesterday, the data is stored in something like this. So first divide the data into row columns, and then you so row groups are divided, and then you basically write your data in a row format for each row column. And the data is not written in the row format, the data is basically written in the column format. So you write it something like this. So same thing happens over there also, but only the thing is, rather than writing this whole as CR1, that correct value, it does the encoding. Oops. It does the encoding. So यहाँ पे exact value क्या जाए, it encodes the thing, so that makes it extremely fast. So if this was 100 and let's say column integer, so यहाँ पे it would have written something like 0, and if it is 101, it has written something like 1 and kind of thing. So encoding and other things are makes it extremely fast, but I'll look more deeper into that part. I have not looked deeper into the Parquet files exactly as a format.
So as you have touched the file formats, these file formats, when do we create it? So my question is, if I'm getting a mainframe data feed, or I'm getting any kind of .dat data feed, how do we use these files format, and when, which area we would convert those file types, those data inflow into these specific files?
So your interfaces to the system would make these things change to the corresponding file format. If you are using a scoop, you can just define what is the file format you have to create while importing the data. So that will create the corresponding file format while importing the data. Or if you are using Zoom kind of thing, so you will just define what is the file format. Or if you can get the raw data dumped into your HDFS directory, then run your cleansing processes, which would cleanse your data and figure out the basically extract out the correct data for you. And that cleansing process will, as an output, will create the corresponding file format, and that file format will be used for any further processing. So at n
So
number of steps, you would be changing. Indeed, in a same data life cycle, you might be changing 3 different file formats, the 3 different life cycle part, or basically instances of the same data. So some data might be, so if you're getting the raw data dump, that data you might be putting in the same format, how whatever it's coming up, and you might be just compressing it. And then you do some cleansing on that data and you create a file format, let's say sequence file out of that. And then you basically, extract some data and meaningful information out of that data and create hype tables on that. So you might be creating ORC or Parquet files out of that. And those Parquet files will again recreated based on the summarized data which you create out of that. The same data might be placed in 4 different file formats, also based on your requirement, what you are doing with the data, as well as what you would be doing with the data.
okay, so let me elaborate some use cases over here. Suppose we are bringing the entire emails to a Hadoop-based system for archiving and for some specific searches. So those emails inflow would be in an enterprise, maybe 1 million email on a daily basis. And in this specific use case, so I'm just talking at a very high level. If it is 1 million email daily inflow, what kind of tool I should use, what file format, and where should I get converted this file, or just a raw file, which may be MSG, would be good enough to save in Hadoop?
So the problem with, if you start saving MSG files into Hadoop, in a day you will be creating more than 1 million files in the Hadoop file system. And as I told you, this is a file system which supports bigger files rather than chunks of small files. So if you just start dumping MSG files into Hadoop file system, your name node will basically, have a lot of extra work to do with managing all those .msg files, 1 million MSG files a day. And that will make your name node extremely slow, and it's all the memory RAM would be just filled up with maintaining the information about which files are lying where, because the number of files would be too high in the system. So either you can group which merge the n number of different MSG files and create zip files, or you can use sequence file as a container to put your MSG files. And the practical use case which I can see with emails is you might be searching up texts, or you might be doing similar things on the email, or doing some analytics or ML kind of thing. So for searching up kind of thing, you might be using Solar or similar thing to index your data, and Lucene or Solar kind of thing to index your data, and doing some searching on the email. Or if you have to do some particular extractions, then you might be writing your own data flow pipelines to do some extraction on the data. But practically you might be storing them in sequence file kind of thing, or you would be zipping together hundreds or millions of email together and creating one single zip files.
Okay, so you touch you touch the solar aspect as well. Now the next question, if I am working on a solar, because I have to retrieve this data for several different purposes. So I would definitely have a search engine which is using solar. Now in that situation, will a zip file work, because my messages are grouped under zip and a particular text search, a particular pattern search can be found? Should I rephrase my question?
No, I got a question. I'm just thinking how that would work. Definitely there should be a way to figure them out. It should be able to do that. How will do that? I have to check it out, but it should be able to do that. Because normally the data is compressed, and uh, I can try to run it up and check it out, but practically it should work up. Either we could define the uncompression, and for the Solar there would be some configuration that will uncompress the file, do the indexing, do the indexing for the corresponding text, and then search it out. There would be some way. Practically there would be some way. I'm not sure how that will possible, but there should be some way. The caution is extremely valid. I totally agree with your caution. Need to check it out. We can run it out and try it out. Solar with zips
Sure, Mira.
or
So
BZ zip.
these could be
I
few
can.
use cases we could take it forward and have work it out. I would ensure that my team over here is working on such use cases so that they would upgrade their skill set as well.
So we can try it out. We can do some POC on this part. So if I get a time, I can try it out, or you can try it out. And there would be definitely some configuration. It cannot be possible that configuration won't be there to read it from the compressed files. There would be some way either in Solar or Lucene, because practically you won't be keeping your unindexed data. So need to be checked out. Okay. Any other question? No? Okay. Okay, so we looked at different file formats, and thereafter, before that we looked at how the data processing really happens with the help of job tracker and task trackers. So, but there were some issues with job tracker and task tracker as a as an architecture, and that's where the Hadoop Yarn come in picture. That is 2.x architecture which came in picture. So Yarn is basically Yarn is yet another resource negotiator from Hadoop. What are the problems with the previous architecture was? So as I told you in the previous architecture also, if the job tracker the process dies down, so I hope you all can recall what was job tracker and task tracker. If you can't, just do let me know. But I'm assuming, safely assuming, that you all recall what was job tracker and task tracker. So if the job tracker and the process dies down, all the information of what has been done by different task trackers and what is the task given to a task tracker and what is the state of a task tracker, all the similar things are not possible in the system because job tracker had all that information. So this was a kind of single point of failure in the Hadoop 1.x architecture. Moreover, there were issues with the scalability of the cluster. So as this was a single guy managing all the task trackers which are running in the cluster, there was a limit to the scalability of the cluster beyond 4,000 as a node or 40,000 concurrent tasks. There were issues with the vertical scaling of the job tracker. So job tracker could have been vertically scaled to a limit, and as I told you in the previous classes also, and I highlighted, implicitly highlighted in the first class, there's always a limit to the vertical scaling. So there was a limit to the vertical scaling of the node where the job tracker is running up, and beyond 4,000 as a nodes to maintain by the job tracker or 40,000 concurrent tasks, it did not give any good performances. And if you have to restart this guy or restart this node, that was really a tricky process. There's no way we can do some rolling restart kind of thing or similar thing because this guy was maintaining each and everything. So there's something new which came in picture. So rather than job tracker, there are few new things, and rather than task tracker, there's something called node manager. So the responsibility of this job tracker has been divided into two parts. One is a resource manager, one is a application master. So what happens is, before that, so this resource manager contains the information about the resources in the cluster, nothing else than that. It just monitors and manages the resources in the cluster. It do not coordinate for any of your jobs. So this guy is responsible for managing the resources which are there with all your data nodes. So there are processes called node managers which keeps on running on your data nodes. Previously these were task trackers which are running up. So instead of task tracker, there's a process called node manager which is running on your data nodes. And these node managers continuously interact with your resource managers, send their heartbeat signals to this resource manager, so that resource manager knows what is the status of these node managers as well as the resources which are free on these node managers. So if anyone wants new resources, they coordinate with resource manager, tell them I want so and so resources on the cluster to run my program. Resource manager can coordinate with the node managers and get the resources for the clients if they want some resources from the resource manager. That's only the responsibility of the resource manager, nothing more than that. It manages the resources in the cluster. And node manager again manages the resources on the node and or initiate the tasks for you on the node. And everything runs in a container. So what happens is,
Miran, I mean, when you say resource, what do you actually mean by resources? You mean the data nodes which are available?
resources means the RAM which is available and CPU which is available in the cluster for you to do the processing. So all the data nodes have dedicated RAM for the Hadoop and corresponding CPUs are available for the Hadoop process to run up. And those dedicated thing which has been available for the Hadoop, on that you run your map or reduce programs to process your data. So this resource manager manages the resource across the data nodes in a cluster. So these are 3 data nodes in the cluster. So this resource manager will keep on coordinating with all the 3 data nodes and will monitor the free resources and the utilized resources on all these 3 data nodes.
Okay.
Um, so what happens is when I as a client send an information to run a job, or basically triggers run job. So what happens up is we coordinate with resource manager. Resource manager will and basically okay. So before going to that, so I hope you can recall what we talked about in job tracker and task tracker. So we copied the resources, that is the jar file to HDFS, which contains the logic need to be run up. So we coordinate with the resource manager to submit a new application. We copy the job object is a part of this guy that runs on the um, so this is what we could trigger, what is back in the backend triggered with Hadoop jar command. So that copies the jar file to HDFS and submit the application to the resource manager that this is a jar which need to be run up. Resource manager will start or request one of the node managers which is free, which is having some resources to start an application master. And this master will coordinate everything for you. So the task which was done by your task tracker for all the jobs which are running in the cluster, that is done by the application master, but this application master is coordinating only the application which you as a client have triggered up. So if there are 100 jobs running in the cluster, there will be 100 app masters which will be running in the cluster. So we divided up the things which were done by your job tracker. So what happens is I as a client request with the resource manager, I want to start a new process. Resource manager coordinate with one of the node managers and ask that guy to initiate one new application master. Now that application master will get the split information from HDFS, and based on that split information, it will ask the resource manager, these are the number of resources I want to run my program. And resource manager will give him the information. You can go and coordinate with so and so nodes and you can run your mapper reducer on those nodes. Then this guy will coordinate with those node managers, will get the resources on those nodes and will start its mapper and reducer program on those corresponding nodes. Make sense?
Miraj, so the first node manager which was called by the resource manager, so the app master will also give some command to the current node manager also, and if required, he will then ask for next node manager, right?
No, this application master will not give any command to the node manager on which it's running up. Indeed, this guy do not knows anything about what there is something called node manager. It can only get resources from the resource manager. So no one is authorized to give resources by their own.
Okay, so this app manager master, what he will do is he will contact resource manager. Okay, I need
this resource manager can tell him that on the same node resources are available. So in such a scenario, it will coordinate with this node manager and initiate another container on the same data node and can run the mapper reducer on in that container. But
yes,
to which node manager it has to contact, this information cannot be automatically depicted by this application master. This need to be coordinated with the help of resource manager.
makes sense. Yeah, correct.
So resource manager is a single point of coordinator to get any resources in the cluster.
So, Miraj, what happens if this goes down then, resource manager?
So if resource manager goes down, there is no failure in the cluster. Only the thing which can happen up is your applications cannot process further to get the resources, and this resource manager can be made up again. And in that case, it will just coordinate with the node managers and get the free information and start giving the new resources to the cluster. So nothing will fail if the resource manager goes down. So there is no single point of failure in the cluster with such an architecture.
So what is the role of node manager actually, except for calling the app master for the resources?
Node manager is a process which is running on all the data nodes. So one node manager is running on each of your data node, not more than one, not less than one. This node manager manages the node itself, the data node. So all the interaction with the node for the resources and similar things are happen with the help of node manager. So as I told you, the task tracker, uh, this task tracker which are running up on each data node. Similar way, there is a process called node manager which is running on each of your data node. And initiate the task on that data node. Same is the work being done by the node manager.
So in a way, is this a combination of both the things, like task tracker and task
Yeah, definitely.
manager?
So it's all about divide and rule. We have more divided up the things to rule up the things.
Yep.
Uh, Miraj, in that particular one, in the earlier one, the task tracker used to send to the job tracker how much it has completed on that particular information. Here, app master will send that particular information.
So here, that information will be with the app master. So if you remember, any process which we ran yesterday, is the cluster running? Yeah, it's running. So oh, the output directory is not there. So see, we are on the application master page of that corresponding application master, and that gives me the information about the what is being done by the what is being going in the application. So all that information is now managed by the individual application masters. So if you go to the 127. So I'm going to the resource manager UI. So this resource manager has the information of the application masters which are running up. I can go to any of the application master, and that application master will give me the information about what is going in that application. And that application master has the information on the number of mappers in the program, number of reducers in the program. So this is the mapper which is being run up. So all that information is coordinated by the application master. Make sense? And also, as this role manager knows the what is in the cluster, so you can look at it gives you all the information in the cluster. So right now there is no queue in the cluster, there is only one default queue, and okay, nothing is running now in the cluster, so it would have shown you how much is the queue full and all those things. It also shows you total memory available in the cluster, total active nodes, total dead nodes, how much is the memory used, how much is the memory free, and all those kind of things for you in the cluster, because this is the guy which manages all the resources in the cluster. So here all the application list will also be available, which have been submitted, which have been killed up, all those things. So the data is lost if a cluster restarts. So this is just showing you two applications which we ran up yesterday only, because cluster has not been restarted from that time. Any other question? Okay. So
Will there be any, Miraj, will there be any scenarios like app master going down or the particular node is not responding or something?
yeah, definitely I was expecting that
So
question.
suppose, because
Mm,
if resource manager tries to access a particular node manager, if that node is not responding, what will happen?
so yeah, I was definitely expecting that question. So basically, if let's say this is application master which is running up on this data node, and this data node goes down. So in such a scenario, first thing is we have not lost any other jobs. We have just lost one job which was running or which was being coordinated by this application master, and that need to be resubmitted. All the others which are running up on this data node and other data nodes where this there is one more application master running up and all those things, those are extremely safe. Or if the node manager goes down, again the application master can coordinate and do up the things, but the job does not dies. So that is what we have achieved by dividing up in the cluster. If that node goes down, definitely we'll lose the job. That need to be submitted because the coordinator of that job has gone down. So this is what we have discussed up. Client submits MapReduce program, resource manager gives the application ID, moves all the resources to SDFS, submit the application. Resource manager chooses one node manager for the app master. Node manager allocates the container for app master. App master grabs the required resources from SDFS, negotiate with the resource manager. App master tells the selected node managers to start the map and reduce task over there. Node manager creates the containers for that guy, yarn, child, acquire job resources from SDFS, and run the map and reduce tasks. Any other questions? No? Okay. So here also you have seen that they also aside Uber mode false. So there's something called Uber mode which is highly useful when your applications are very very small. So what happens up is you can see how much is the backend, or how much is the bookkeeping activities which are really required in the cluster just for very small process. So let's say I have this is my one of the file which is just few MBs and just taking half of the block and in the data node, and I have to process that file on the data node. So one application master will be initiated somewhere, and that application master will coordinate with the resource manager, will get the resources. Then the mapper will initiate on this node and will get the data from this, and then reducer will be initiated on some other node, and this data will be transferred from this mapper to the reducer. Reducer will do the reduce and will output the data into SDFS for just few MBs of the data. So there's a lot of bookkeeping activities and the coordination which need to be done up in the cluster. And that is the reason I told you initially on the first day that there is always a graph, and you have to look at whether your MySQL as a solution is good enough, or your Hadoop as a solution is good enough. And there's an intersection point of always based on the data sizes. So these are the reasons at the backend which are really required up for data processing and similar things, and data caching and a lot of things. So Uber Task helps you in only in the cases when your file is very small. So what it does is, rather than creating this mapper class, and all reducer objects and all such things, what you can do is that file processing starts itself on the app master, because that app master has the RAM allocated to it, so that a small file can be processed just on the app master. So the mapper and reducer are initiated itself inside the container of app master, and the processing is done inside the app master itself. So that reduces all this booking activities and similar tasks which need to be done up for very, very small files. And what is the definition of small files and similar things? Those are all configurable. So if you enable the Uber, by default these are the configurations, but you can change them in the configuration files. Any questions?
What if we have a very big file with very huge amount of data in it,
So same
and it
thing.
is like not splittable, and it has only one mapper allotted to it? So how can it run it on the mapper like
So again,
map
that is
app
that,
master?
that is based on the configuration I told you. No? So if your that file criteria lies in this application, that is input size is less than so and so. If you've defined that thing, then it will be initiated in the same map master. Otherwise, a new mapper will be created up. And for single splitter, definitely only one mapper would be there. All the data will be transferred to that mapper node for the processing. Make sense?
Yeah.
Or if you were to change this definition in the configuration file and you would have made that a 10 GB, so yeah, definitely that could have been initiated on the app master only in the open mode. So these guys keeps on sending the heartbeat signal, as I told you, update status, and you coordinate with the app master like we have seen in the UI a few minutes back, and that gives you the information about what is the state of the job. So rest all, or some ports which are changed, some file configuration which are changed in 1.x and 2.x and similar things, which are not required right now, but you can read them if later on. So any questions on the yarn as an architecture and how that resolves of the thing which were issues with the job tracker and task trackers? Okay, I'll assume no. So then we'll start Hive, and this would make sense to a lot of you, because this will give you an interaction with the Hadoop file system in the SQL format. So you can write a SQL queries and get your data processed at the backend.
So
Oh,
before you forward, what all are the file format which would be allowed under Hive query?
anything what we talked about, everything is possible, because that Hive will be reading the data with the help of HDF. Oh, sorry, input formats and output formats only. So you have to just define what is the input format you want to use and the output format you want to use, and Hive will use it. So that's the beauty. At the backend, Hive is writing the MapReduce code only for you. So if you understand what is being done by the MapReduce, everything is possible in Hive. What is being done in the MapReduce? It does give you a lesser code, fast learning curve, and for database guys, there's no learning curve which is required. You just start writing your SQL queries and start processing the data. But you need to understand what is happening at the backend so that you can read different file formats and do all those things. You should know that there's input format which comes in picture, output formats comes in picture, and all those things, so that you understand the complexities in the cluster, and you can optimize your queries and similar things. Okay, so we'll start Hive, and before that I'll grab a glass of water. Okay, so Hive was basically developed with Facebook, and it gives you a feel of relational database on top of Hadoop. So you can create your table schemas, you can support partitioning, clustering, complex data types, and a lot of optimization with the help of Hive, what uh, would have been possible with the MapReduce also, but the complexity of code which is required at the backend to do those things is extremely high, and the learning curve is again a big challenge. And for people not from the background of Java and similar things, it's extremely challenging task. So and then there's a lot of MapReduce chaining which you have to write up. Single MapReduce code will not suffice all the things. There will be all complex queries which you might be requiring up to run up. So for those things, the MapReduce code which is required at the backend would be not too long. So it can handle unstructured and structured data, both the things. How it can handle, we'll look at in some time. So if you remember the word count program, the MapReduce word count program which we looked at, that had around 60-70 lines of code. The job configuration, the mapper class, the reducer class, then the reducer class. On the mapper class, we split the line into words and imitate word comma one. On the reducer part, we created a for loop, iterated on each of the values for each of the key, and then imitate key and sum of values as an output to get the word count. So that 65 line program can be written in just 2 lines in Hive, and that will give you the word count. What we are doing in all these things, do not worry about the complexity, or we'll look at all those things. But what I'm doing here is I'm creating a table on the file on which I want to do a word count. And then I'm doing select word and the count start from some lateral view. There's something which is happening up. And that is giving me the word count, what was being done by the MapReduce program. So this example is just to give you how easy it is or how lesser amount of code which is required up to get the same things done with the help of Hive. So let's try to run this word count program. That will give you a little feel. And don't worry about the complexities what we are looking into the slide. We'll slowly and gradually understand them. So go to to go to the Hive console, you have to just type Hive HIV and press enter. This will take you to the Hive console. Oh, it's getting too slow. I'll stop some of the things which are running in my PC to make it a little faster. Just to wait a minute. A lot of things which are opened up in it's not able to initiate the Hive Metastore client on my PC. I'll just try now. I've closed a lot of things, so I'll just try back again. Uh, just give me a minute. I have to just check what is the problem in starting Hive. So I'll again pause my screen. I'll just cross check what is the problem with Hive. So by that time, if you are running your virtual boxes, you can just try typing Hive and that will take you to the Hive console. And if you try commands like show databases, show tables and similar thing over there, that will show you the databases, show tables. So similar to your MySQL or any other relational databases, the commands would work on that same console. You can just try those things by the time and give me just 2-3 minutes. I'm just checking it out. What is the issue? BRB. What does that mean?
I'll be right back, Mira.
Oh, okay. Be right back. So yeah, Hive server started now. What is the problem happening? So yeah, it started. It's little slow. I'll just check what all is taking a lot of CPU. running slow. Okay, finally loaded. So this is a database I'm going to. Interesting. No problem. Okay, no worries. We'll create our own table. I don't know. So what I did is I created a table which is pointing to a file which is lying at that location. I'll just cross check if there's some file lying at that location. If not, we'll create some file and we'll just put some words and dummy words in this at this location. So I'll open the Hue browser and we'll just check if there's some file lying at that location. If not, I'll just create another file at that location. So I hope you remember 8000 the port for the Hue browser, and from there we can browse the Hadoop file system. Or to check if there's something lying, I'll just say select star from doc. Probably there should not be any file at this location, but we can cross check it. Nothing. Okay, not a problem. So I'm going to this location. Okay, this directory exists, but there's no file. So what I'll do is I'll create a new file over here and just say abc.txt. And would put or write some words inside that. So we'll just copy this thing only, Control C, and open this file, edit the file, and Control V, and save it. Okay, so now if I do select a star, it shows me something. Okay, so now to a word count of this program, what I did is, right now is I've just created a table which is pointing to this file, nothing else. And I've created what would be the columns in my table. So I said text string. So again over here, if you can recall what I talked about in your input format classes and output format classes, by default which is the input reader which is reading your file. Can you recall the default reader?
That is one which reads on the next line reader.
Yeah, text input file format.
File reader?
Yeah. So that is reading data line by line. So here you can see it has read the data line by line and it printed and each line is now a row to my file. Oh, sorry, to my table. I've created only one column, that is text string. So each line will become this text, and it started printing that each of that thing as a row. So now I've got the data of the file read as line by line, and each line becomes a row in my table. I'll just apply SQL function on that thing and we'll try to produce the word count. So we basically split that thing into spaces and do a group by on the world. Don't go into the complexity right now. And so that is now running a MapReduce code for me. You can see it has created the mapper at the backend, reducer for me at the backend. I don't have to worry about the complex Java code. It has done all that thing. It will run that thing and will produce the output for me. So it will take little while to produce the output. We can come back to this thing in a minute or so, and all the that application browser and application master, everything would be browsable from in the same way. It will create the some application master for us. Here you can see, okay, till now it's not started. So it started probably. No, still unassigned. So right now the backend negotiation with the resource manager and all those things are going up. So that number of mappers, number of reducers and all those things going to be browsed from here. Okay, so it will take a while to run up. So by the time it's run up, we'll again proceed further and then I'll show you the output.
Miraj, I was
Yeah.
trying to browse this Hive. Can I once share my screen?
Okay, just give me a minute.
In the Hue, I just see these. Can you see my screen?
Yeah, I can see you.
Yeah, in the Hue, I can see these folders. You mean to say that I need to create that Hive and that DB path and
No, you
those files?
no, you can point it to anything. SJFS में कोई सी फाइल पे point कर सकते हो, not necessary to make it Hive folder or anything like that.
Okay.
Point it to
I can
input
hold
only.
a point to this particular
Text dot
text
text.
file, right?
Yeah. So you can just give input as user Hue input, and it will read the data from your folders. So
Because I got this.
practically you basically you create tables on the folders rather than individual files, because your folder would be containing your hundreds of files, which is a dump of messages, like communities are saying we are getting thousands of millions of message files. So you'll be pointing your table to a single folder rather than a file practically.
Okay.
So ls will not
Okay.
work on the Hive console.
Okay. Then I
Press
just need to create that.
Press semicolon and enter.
Okay.
Semicolon. Oh, sorry, not that colon. Sorry, colon, not semicolon. I can't see it properly. I think you are pressing colon. Semicolon and colon are on the same keys on your laptop. Colon. Yeah, this one. Yeah, now you can create a table and point it to this
Okay.
location.
Okay. Okay.
Okay. So I'll take back the console. Okay, so we just created a table, and so basically before going to the deeper, and is that output here? Okay, output is here also. So see, it has given me the output, and I've got the corresponding words and the count of those words. So here the space between word, basically, we were expecting that words are separated by single space, but these were separated by tabs. So that's the reason this is considered as a whole word rather than dividing into the words, because we have divided them into spaces. So that's the reason this whole line is considered as a word. Okay. So as compared to your any other thing, it also supports a lot of different data types, small, int, big int, boolean, float, double, and complex data types like structs, maps, and arrays. So map is nothing but a key value pair again, guys. Struct is a combination of your data or a group of your data, and array is, and again, list of values. So each table has a corresponding directory in the SGFS which it would be pointing to. And so let's say I've created a table called design Pathshala. So there would be some directory in the HDFS com/design Pathshala on which this table will be pointing to. It's not necessary that the table name should be matching with your directory name, but it's good to have that same thing for the future references and not to create confusion with. So it's a kind of best practice to have that same name. So this is how you create a table. So similar to any of the SQL word, you create a table with giving a create table command. So create table, your table name, then the columns in the table. So here I've created the first column as a string, another column as float, that is salary for the design partial employees. Then subordinates, that is the employees which are subordinate to this employee, and that's a list of employees. So we created an array. Then the deduction, that is a deduction which is there on their salary. So there will be a number of kind of deductions like cut for taxes and all those kind of things. And then the address of that employee. So that is an struct, street, city, and state and zip kind of thing. So this is how you create a table. Comment is nothing but you can associate a comment to the table, which is nothing but for the future reference, you knows what is this table for. Partitioned by will look in some time, but if you understand little bit of the SQL context, you can easily guess what is partitioned by. A row format delimited by, fields terminated by, collection items terminated by, map keys terminated by, and lines terminated by. This is what makes this guy understand how to read the data lying in the file. So this is where your corresponding input formats and what kind of record reader will be used up to read your data. That is what comes in picture. So here what I said to this is lines terminated by /n. That means each new line in my file will become a new row in my table. Same thing I gave over there also. A row format delimiters, fields terminated by /n. So each new line in my file will become a new row in my table. And rest are the configuration how to read or figure out the different columns from that row. So practically /001 is nothing but the control A from your keyboard, /002 is nothing but control B, and /003 is nothing but control C. So why I've used this control A, control B, and control C in this example is because these are by default configuration in your Hive word. So if you don't give them, these are default configurations which are taken care of. So that's the reason I'm trying to show you the default configurations. You can change them, anything other than that. So what I'm saying is fields are terminated in this row by control A. I would have given this as a comma also, and by that virtue of that thing, I would have read a CSV. So what I'm saying is each new line in my file is a row to my table, and how to read that row? This by these three lines. So anything which is separated by /001 will become a new column. So if there is A and then control A and then B and then control A and then C and then another line D, control A, E, control A, F. So this will become your first row, this will become your second row, and A will become your first column, B will become your second column, C will become your third column. Make sense? A quick yes no will help me.
I'm slightly confused, Viraj.
Slightly confused. Okay. So let's say this is the data.
Can you actually put it in tables, I mean rows and
Yeah.
columns?
Yeah, so
Like
let's say this is the data. This is the
It
data.
helps. Yeah.
And so Zodo, control A, something control A, control. So here what I said is, okay, before that, okay, let me open an Excel sheet. Excel sheet पे होगा नहीं काम. So let's say this is my data A, comma B, comma C, comma D, E, comma F, comma G, comma H, I, comma J, comma K, comma L. Okay, I created a table. Create table. My table. Call one string, comma call two string, call three string, call four string. And what I am doing, and what I'm saying is row format delimited, how the rows are delimited. So this is what it tells it. And then what I'm saying is fields terminated by comma and lines terminated by /n and stored as text file. Okay, so what I'm saying is each new line in my file is a new row to my table. So ABCD will become one row, this will become another row, IJKL will become another row, ABCD will become another row. Because I say lines terminated by /n, and fields terminated by comma means each thing prior to a comma will become one column. So here first column will become A, second column will become C, and third column will become third column will become C, and fourth column will become D. And similarly E, F, G, H, I, J, K, L, and so and so. Make sense?
Yep.
So what we are doing over here is we said fields are terminated by control A. Collection items, that is any collection which is used in our as a complex data type in our table, those items will be terminated by control B. And map keys and values, so if there is any map which is used in our program like deduction map, so its keys and values are terminated or separated by control C. So if this is my data, Zondo will become my name for the first row because fields are terminated by control A. Then anything after control A will become second column until unless the third control A has been deducted. So this thing will become my salary for this Zondo. Then this thing will become my third column, that is subordinates. So subordinate is of type array. So how to figure out different values of an array? So those are separated by control B. So Mary Smith will become array, the first element of the array, and John Todd John will become second element of the array. And federal taxes till here will become my third column, or sorry, fourth column, that is deductions. So these are my deductions which are applied on my salary. So federal taxes, state taxes, insurance are three deductions which are applied on my salary. So what I said over is anything which is terminated by control C is key and value pair separator of the map, and control B is separator of anything which is of type collection. So a map can have n number of keys and values. So control B is separating those keys and values, and control C is separating key and the corresponding value. So federal tax is 0.2, state tax is 0.5, insurance 0.1, and then the address. So anything, so this is my address, and this is slash and new line character. So this will become my address. So 1 Michigan A will be my street, Chicago will be my address, city, and IL will be my state, and 606,000 will be my zip code. Make sense? And after that, I will have another row, and another row. Okay, I assume it makes sense. So this data could have been written something like this also in a JSON. There also we would have just used the JSON survey, and we could have read the same data, which is written in another format. So I'll show you how to read the JSON data. So before going over there, let's look at some of the pretty normal commands. So I'll assume you people all are aware of these commands, so I'll don't take great time to explain each and every command, but if you don't understand any of this command, do let me know, I'll explain that thing. So create database will create a database for you. So here I'm saying create database design Pathshala will create a database design Pathshala for me. Create database if not exist design Pathshala. So create database design Pathshala will give me an error if the design Pathshala as a database exists. But if not exist, will check before creating it, and it will not throw any error. Show databases will show the databases. So right now there are two databases, default and Exademo. So I'll start the older version because this version is little heavy. So by the time will come that will start up. Okay. So these databases, so there is a directory which is associated to a database, and all the tables are by default created inside that directory. So this is all configured where to create our databases. The default location is /app/hive/warehouse and the corresponding database name. So if you go to the location in your SDFS file system, you will see, and if you create any new database, that database directory would be created in this directory. Although you can change the directory where your database need to be created up, but this is the default location if you don't give the location with the database. So here you see I have given create database command. I have not given any database directory. So by default the design Pathshala.db directory will be created at this location. Or you can explicitly give the location where you want your database to be pointed out into the SDFS file system. So this is how you can give the location. And comments is nothing but what is this database all about. Describe database will do the description of the database, will give you the database location and if any comments associated to it or any other particular properties associated to it. CLI Hive is nothing but when you go to Hive console, this will show you the database name also on which you are using up. Drop will drop the database. Any questions?
I'm good.
Okay. So while creating a table, as you've seen in the first example, WordCount example, we give the location. So if we give the location, the table is pointed to that location. If we don't give the location, a new directory will be created up for us in the database directory, and the data would be read from that directory. But by default, the data would not be in that directory because that is a new directory created by Hive. So it's your responsibility to insert the data into the table. And that's where your data pipelines comes in picture. You will create a table, insert the data into that table, create some third table from that table, and that's how you will create your data pipelines. So create table if not exist is similar to if the table does not exist, this will create a table, otherwise it will not throw in any error. Show tables will show the tables in my database. If this is started, let me show you. So instead of putty, I use kitty that stores the password also for me. Show tables in particular database, show tables like something. Describe table will describe the table and its properties. Describe extended my table will describe the table in extended format. And show create table will show you the create table script which was used to create the table. So I'll show you describe the table name in few minutes once this Hive console is up and running. So as I told you, when you do not define the location of the table will be created in the default warehouse directory of your database. And if you drop the table, it also deletes the data. So there are two kind of tables. One is called your external tables or managed tables, and one is called your internal tables. So try to understand this thing. If you don't understand this thing, you might create sometime havoc in your cluster. You might create your all of the production data kind of thing. So there are two kind of tables in the Hive world. One are called your managed tables or external tables. One are called your internal tables. The major difference between external and internal table is when you create an external table, you define the location where this external table is pointing to, and when you drop that external table, your data is not deleted. Uh, oh, sorry. So a managed table or internal table is the same thing. However, external table is a different thing. So managed table and internal table is the same things, or these are same words which are used for similar table, and there's something called external table. So managed table or internal table, if you drop a managed table or internal table, the data associated to the table is also deleted by Hive. However, when you drop an external table, the data is not deleted. That is a major difference between managed tables and external tables. So as the name suggests, managed table, these tables are managed by Hive. However, external tables are external tables, and those are pointing to some data which is lying at a particular directory. And if you drop that table, the data is not deleted. So that is the major difference between internal tables and external tables. And I'm sorry, managed table is managed table is a word which is used for internal tables, not for external tables. So, अबे यार ये क्या हो रहा है? Just a minute. Why is it to? So what I'm trying to do over here is, this is a good thing for you who, so if you are managing a on cluster, you don't have an admit in. So this is how you will be looking at different problems. So right now I was facing issues while accessing Hive. So I gone to the Ambari UI, checked the Hive, and I see the Hive server 2 was stopped. So I came over here and clicked on the service actions and started this guy. How I got to know, I just grab Hive server, and it shows me there is no Hive server running up. So now the Hive Metastore is started and Hive server 2 is still running up. Hive Metastore is the guy which maintains all the metadata which you are storing up for the tables, and Hive server is the person who really your Hive clients interact with to run your Hive queries. So it's just starting up. From here you can look at the logs also, or you can go to the corresponding nodes to look at the logs. So here you can see the logs. So if you face any problems, you can go to the directory logs and check the logs over there. So we can just say tail minus 200 F, and we can look at the logs which are generated while this Hive server 2 is starting up. Still starting. Okay, there is no error till now. We can just check the output also. So starting up, Tage is another concept. If you integrate your Hive with Tage, Tage is said to be 100 times faster, but there are other complexities which might come in picture. But definitely, if you just say Hive to use Tage as an execution engine, Tage is said to be 100 times faster as compared to native MapReduce. Claim to be. So it's still starting up, taking a lot of time. Started. Okay. So now I can go to the Hive console. You got it what I did? I was facing issues with my Hive. When I typed Hive and pressed enter, it was throwing me some errors. So I checked whether the Hive server is running up or not. So what I did is I just typed ps-ef grep Hive server 2, and it showed me there is no process by that name which is running up. So I gone to the Ambari UI, checked, click on the Hive, and also still the connection is still refused from this. So health check is still not being passed up. And started it from here. So now the health check is passed up. Now everything is running for the Hive. So now this one, the alert will go. It gone. So this is what is the use of Ambari UI. So now I am on the Hive console. So if I say show databases, it will show me all the databases. I'll say use DP. So it will take me to the DP database. Now I'll say show tables. It shows me all the tables. Describe this table. So this will show me the columns of the table, and if the table is partitioned by, on which it is partitioned by, and so on and so things. If I say DSC, EXT, and DED extended, stocks partitioned. So it shows me a lot of other information which will make sense for you now. So here you can see database to the which table is associated to owner, the user who is owner of this table, credit time, last access time, and a few other important things. Location where the data, or the location which has been pointed by this location, or where your real data for this data table is lying up, and the compression enabled on this table, and input format which is used to read the data from this table, and output format which is used to emit out the data to this table. So the default are used because this is a text table, text input format and text output format. So this is where you can just use any of the file formats which you want to use up. You have to just define your input format and output format which you want to read the data, read and write the data in the format, and that's a virtue by which you can read the sequence files or any of the files. And you have to just define the compression, and that by the virtue of that you can read BZZip or LZO or Snappy or anything. So is it too easy today, or again it's little confusing, no voices? So
This is interesting. I can say.
okay. So external
And
table.
at least we're out of the Java world, right?
Yeah. So but now you understand just the concept. So this will things will be easier for you to understand what is happening at the back end. Okay, so external table, as I told you, you have to, that table will be pointing to some location in the database, definitely mandatory. And if you drop this table, the data will not be deleted. So if some external table is there, I'll drop it. I'll check this table, or let's try show, see, create table. So this will show me the create table script. Acha, this is some JSON table, so I have to add the jar of JSON survey. I'll use some other table right now. Okay, so this is the intern table. So if I don't say explicitly external over here, this is intern table, and this is pointing to some symbol in directory this. Just use dpdb temp. So if this directory is there, we'll just check. Acha, temp directory is not there. So we can create a temp directory, not a problem. New directory. Temp. Okay. And we'll create a new file in it. So although the table is lying up at the back end में से किसी ने डेटा उड़ा दिया है. So किसी ने डेटा उड़ा दिया था, मैं दोबारा से डेटा डालूंगा तो डेटा फिर से दिखने लग जाएगा टेबल में. So I am just creating a file for that table. So this table was pointing to this location, so I created some file in this directory and putting some dummy data and saving it out. And now if I just select star from temp, it shows the data. Okay, now I say drop table temp. Because this is a managed table, temp is directory gone, data is deleted because this was a managed table. However, if I would have created an external table, so what we'll do is we'll just type it over here. I don't want to use any of these things. By default, the default things will come in picture. Location this, create table is created. If I do a select, nothing will happen because this directory practically is not existing right now. So now this is an external table, not a managed table. data is there, drop table temp dropped, show tables, temp is not here. However, the data is there, file is there. So that is a major difference. So practically you will be creating external tables on the directories where your data is coming up from some other sources, and that data is used by n number of things, including Hive table, or that data is useful, then you will be always creating external table, because by mistake if you drop the table, your data is not lost. Inter tables are created for some data pipelines, when you are doing some data pipelines from this table to some other table, and from that table to some third table, fourth table, and the final sixth table. So these third, fourth, and fifth table might be intermediate tables, so you can drop them later on after your workflow has been done up. So that will remove the data which is lying into SDFS and free up your SDFS resources, which might be unnecessarily which might be unnecessary cost for you. Okay, so before going ahead, I think in MapReduce I have not told you people, but now you can just try out to create some table on your Hive console and just try to do a select on the table. That will give you a little feeling what is different between SDFS and similar things, and this would be interesting also for you people. So you can just try to open your VirtualBox and try to open Hive console and just try to create a table and do a select. That's all. So everyone is trying. You can just ping yes or no on the chat window. Yeah, there will be two existing tables which will be in your cluster. One is 007, one is 008 kind of thing, I think. So yeah, you can try on them, or you can create your own table on some file that will give you a. So you can browse all your tables from here. Go to Hive, yeah, Hive, and tables, and here you can see all the tables for your database. So here I can browse the tables. I can just click on this. So this is the table and this is the data in the table. Is everyone able to run it up or running up? So Mandar says yes. Anyone else? Guys, you can ping, just ping yes or no. Apur says yup, he has ran it probably. Ankit also says yes. Okay, so looks like you would have ran it. Okay. So yes, I assume that you have ran it or you are running it. I'll assume you have ran it. So I'm assuming you have ran it and I'm proceeding further. If you want me to stop, do let me know. So partitions give you great power in reading your data and maintaining your data. So practically, when you're getting your data, you would be getting it in every day or some particular frequency. Your data might be can be logically divided into a number of partitions. So what happens at the back end is, so let's say I'm getting a data of emails, or email will be a little confusing, stocks. So let's say I'm getting NYSE dump. So each day I'm getting at the end of the day, at the end of the trade day. So I might create a folder. So my table would be pointing into a directory which is NYSE. So the directory would be practically slash apps slash hive slash where house slash stocks dot db slash nysc. So this is my table which is pointing to this directory. Inside this directory, I might be getting data every day. So I would like to create new folders for each day. So I might be creating folders like day is equals to 20160101. Day is equals to 20160102. Day is equals to 20160103, and so and so till day is equals to 20161231, and so for other years also. And inside these folders you would be keeping or dumping the data which is a dump for today. So when I have to query something from this table, I can just easily say my Hive to look into this partition, and it will be just skipping all the other data. So my reads will be extremely fast. You can further partition your data inside a partition. So let's say I partition my data inside my day data for by stocks. So there will be subdirectories inside my day. Stock is equals to Intel. Stock is equals to Microsoft, and so on. So each directory for each stock, and inside this there will be data for that stock or trades of that stock. So when I'm saying select from table so and so, table NYSE, where day is equals to 2016 1st January and stock is equals to Intel, so I'll be just going to this directory. So I'll be just going to this directory, inside this directory, and we'll be reading the data which is lying over here. So rather than reading petabytes of data which is like in my file system, I am just reading only small amount of data. So my reads or queries on the table will become extremely fast. So partitioning is a concept which is used across the databases, and same as the concept available here also where you can partition your data, and you can just query the corresponding partitions to get your data. Any questions? Okay, I'll assume no. So how to create partition table? You have to just define the parameter partitioned by, and that will create a partition table. And one thing to note over here is the columns which are in the partition by never appear in your columns list. So country and state are not my columns. They are my partitioned by clauses. So by default, when you do a partition by on any table, Hive will create directories by this name. Country is equals to country ka value. State equals to state's value. So this is the default folder name which comes up for you, and this equals to, after equals to, is the value of that corresponding partition. And that's what I've written over here also. You can change this configuration, but I insist not to change this default configuration because reading the data with similar thing is extremely easy, and if you change the directory name formats, later on you would get a lot of issues while reading the data. So you can say country is equals to CA. So in that case, it will go directly to the directory CA and read all the folders inside this directory and will process the data for you. So I'll show you some examples. So here I'm not doing anything, I'm just inserting. So here what I'm doing is I'm creating an table, stocks partitioned, and it's partitioned by trade date, and it's a comma separated table. So to run Hive queries, there are other way. You can just give any SQL or any of the file which you want to run up in the Hive console. For that you have to just type Hive -f and the file name. So that will run up this file in the Hive console for you. So this is another way to run Hive queries, Hive -f. And you have to give the file name which you want to run up. So the table is created. So if I say, so another way to run Hive queries is Hive -e without going to Hive console. I can give my command what I want to run up, and this will run my command and show the output here only. So I say use dp dsc extended table name. So this is the third way to run Hive queries. So the table is created. You can see it's partitioned by trade date, and trade date is not no मैं trade date दोनों जगह दे रखा था क्या? अच्छा नहीं. So trade date is now a column. However, we have not given that as a column in the create command. So if you look into the file, the data will be only till volume, and there will be no data for trade date. I'll show you. We'll insert this some data into this table. So I am selecting it from tables stock, and so stocks ka data I'll show you. So that is column, opening price, end price, and all those prices, and the trade date at the end. Trade date at the end for all the things. So what I'm doing is I'm selecting from this table, and I'm saying I'm inserting it to partition table. So I'm selecting a data from one of the table, which is a dump from my database, and I'm trying to insert it to some another table which is partitioned on trade date. So that's here by the power of Hive you can partition your data. So you don't have to partition it yourself manually. You can use Hive to partition your data, and Hive will create a corresponding directories inside the table directory, which are partition names directories. So stock partitioned में अगर data पहले से पड़ा होगा तो duplicate हो जाएगा. So trade date equals to this, trade date equals to this, trade date equals to this is the directories which are created inside this stock partition. And if you go inside this, there will be files, and you can say the trade date as the last column, or in the data is not there. That is depicted from the directory name. So when I say select start from this table with trade date equals to this, it will just look into this directory and will get the data from these files. Any questions?
So first you ran the command for creation of table where you marked that partition is on trade date, and later when you inserted data, so at that point of time again we need to tell it that okay, this is partition on trade date. Is I'm right?
So here what we did is, so this program is still running up. So this is the older data which is lying in this table. Another एक और यहाँ पे file आ जाएगी, insert हो जाएगा. So what I ran is insert into table, stocks partition was one table. So it ran up. So यहाँ पे एक और चौथी file आ जाएगी because that was insert into. So एक और file आ गई. So कहाँ गया? कहाँ गया? So what I did is I inserted into this table. Table name is stock partition. I have to explicitly tell कि इस table में से जो मैंने columns पढ़े उसमें से मेरे को partition वाला column कौन सा है. So I have to explicitly tell trade date is a partitioned column which need to be read from this table and partition on this column. So this is the column trade date which will be associated to the trade date column of this table, and this is how the data will be partitioned. So in another way I would have written this table something like, I would have written this query something like this. So select A, comma B, comma C, comma D, comma E, and let's say E is equivalent to trade date. So partition by E. So now E will be associated with trade date column of this table.
Makes sense. Yeah, correct.
And if ABCD say इसके column ABCD match नहीं करते तो वो फिर number में ले लेगा. A will be associated to the first column and so and so. Otherwise the name should match.
Okay.
नहीं नेम मैच नहीं करे. ओके सॉरी, अगर नेम मैच भी कर रहे होंगे तो ऑर्डर सेम नहीं होगा तो भी दैट विल क्रिएट इश्यूज. तो ऑर्डर शुड मैच, अदरवाइज यू हैव टू सेलेक्ट इन दैट ऑर्डर. सो ये टेबल में अगर सपोज मैंने क्रिएट करी थी स्टॉक पार्टीशन में, सबसे पहले कॉलम था ए, दूसरा कॉलम था, सेकंड कॉलम वाज लेट्स से सी, एंड थर्ड कॉलम वाज लेट्स से बी. एंड यहाँ पे मैंने अगर सेलेक्ट करा है select A, B, C and partitioned by E. सो वो B जो है C में चल जाएगा और C जो है B में चल जाएगा. सो यहाँ पे एक्सप्लिसिटली मेरे को सेलेक्ट करना पड़ेगा A कॉमा C कॉमा B कॉमा E.
Okay.
यहाँ पर रिफ्लेक्शन वाला फंडा नहीं चलेगा.
Okay. Okay. Yep.
So the people are too quiet today, so we'll wind up. We're already running up with time, so we'll cover up other parts of Hive in next class. And by that time you can just try to run some Hive queries, and then I'll show you how to read the complex data types like JSON and other things which are there over here.
Is there somewhere, some like we can get some list of Hive queries, sample Hive queries? Is there somewhere we can,
Sample Hive queries. I'll share this PPT. You can look at them.
Okay, it should be great. Yep. Yep. Thanks.
Or Mandar, I have shared the code with you. Inside code folder, there is a folder called Hive. Inside that there are a lot of files which I'm showing right now. So all these files are lying in that Hive folder. You can just open them and you can play with them also.
Okay. Okay. Great. Yep. Thanks.
Okay, then we'll then wind up today. It's too quiet today, and it might be too late for you people. So that might be the reason. So we'll talk about other things of Hive in next class.
Right. Thanks, Miraj.
Thank you. Have a nice day.
Thank you. Thank you, everyone.
Thanks, Miraj. Good night. Have a
Thanks,
nice day.
Miraj. Good night.
Good night. So I'll check about the solar, how to read the zip files. Practically there should be some way.
Okay. Sounds good.
Sure. Okay. Bye-bye.